All right, in this example, we're looking at where an airplane is at. We have it starting at some airport here, and then the heading that it takes is going to be 20 degrees north of east. This is one of those things that you have to get used to a little bit, figuring out bearings that they will give directions in the nearest turn direction that they have. So 20 degrees north of east means 20 degrees counterclockwise from the x-axis. Whereas when he later turns the airplane and it is 10 degrees east of north, then you think about the y-axis, and 10 degrees before that, which would be 80 degrees from horizontal. So the thing that we're actually being asked to solve here is to figure out the heading that the airplane needs to take in order to come back home. Now, we did a similar problem to this back in the law of cosines problems, but with the advantage of vectors, this is actually going to be quite a bit easier to work out. So we have to, first of all, think about the first heading that he had, which we'll call vector u. And it has a length of 9, and then the angle that that made with the horizontal is 20 degrees. So we put in cosine 20 degrees and sine 20 degrees. Now, we're going to go approximate those here in a minute, but for now we can just put those in. Then the next heading that he takes here, I'm going to refer to as the v vector, and it is a distance of 5 miles. And if you recall, I suggested that we think about our positive x-axis here, and this angle to be 80 degrees. So we'll say cosine 80 degrees, sine 80 degrees, right? Now, that is fairly nice for us to do, because now our position that the airplane is at is u plus v, and that would, in fact, just be the vector that has taken us along here. So once we calculate what u plus v is, we can just take the negative of that, and that's the heading. We'll need to put it in airplane terms, of course. But if we come in here and say that this is equal to 9 cosine 20 plus 5 cosine 80, comma, 9 sine 20 plus 5 sine 80, we can go to a calculator, and we get about 9.325, comma, 8.002. So in order to head back home, we are going to think about it as being just the negative of this. So it'll be the vector negative 9.325, negative 8.002. So if we think about where that is for headings, then that is going to be somewhere roughly down there in the third quadrant. So when we make reference to this angle, we can either refer to it being south of west or being west of south. It looks like that this angle here is going to be the smaller, so in airplane terms, that's what they would in general do, give you. So we're going to think about the vector, or the angle that we need, as being this right here, and we can just look at it like doing something with a right triangle. Of course, this side of the right triangle is going to be the 8.002, and this side is going to be the 9. You know what? I'm wrong. So let me back off on that before I make a further mistake. That is going to have a larger x component than it does y component. So we're going to think about this right here, which is nice because it makes it seem like we're dealing with a reference angle. So what we're going to think about is having this negative 8.002 and this negative 9.325, and we're going to say that the tangent of that reference angle is going to be the negative 8.002 divided by the negative 9.325, which is about 0.858. And when I take the inverse tangent of that, then I'm going to get about 40.6 degrees. So, in answer to the actual question here, the heading that the pilot should take is about 41 degrees south of west.